everyone. I'm Suhail. Very excited today to talk about our recent paper on the ZTF Type Ia supernova survey, its first data release and results. I'm a new Marie Curie fellow at the IOA in Cambridge, but a large part of this paper I did when I was a postdoc at the Oscar Klein Center in Stockholm. I'll be giving a few brief results, but the archive ID and the journal link is here on the slide. And then finally, just giving a few takeaway messages. Just a brief background. So the Hubble tension is the largest open question in cosmology right now. So this is a discrepancy between the inferred value of the Hubble constant from the early universe and a direct measurement from the Cepheid distance ladder in the local universe. So as of the latest SHOES release, this is a tension at the 5 sigma level. And with its profound implications for particle physics and cosmology, like potential additional neutrino species or dark sector interactions, it is very important before concluding that it is new cosmology that we look for all potential possible sources of systematics as to whether or not they could be an explanation for the observed discrepancy. So one potential such systematic is that because Cepheid variables prefer young environments of type Ia supernovae, could that potentially be a bias in the local measurement? Now, the ZTF sample is ideally placed to answer this question because ZTF searches and follows up type Ia supernovae from the same survey and instrument. So we see this all-sky distribution of the year 1 sample is already a lot larger than the amassed low redshift anchor sample for cosmological analyses. On the right-hand side, we see the host galaxy mass distribution, comparing it to the current low Z, and we find a lot more type Ia supernovae discovered in low mass galaxies compared to the current low redshift anchor. So we're getting close to probing the underlying distribution and therefore looking for what the impact of host galaxy systematics will be. In addition to H0 measurements, there's a lot of new science that can be done with this sample. So because of its all-sky distribution, we can use this sample for local large-scale structure studies, for example, measuring growth of structure in the nearby universe. This is very important because there's another cosmological tension, which is between the weak lensing measurement of the growth of structure and the inference from the early universe using the CMB, and therefore type Ia supernovae being completely independent and at a different redshift region in order to arbitrate the origin of this tension. In addition, because of the large statistics and all-sky distribution, we can also test directional dependence of cosmologies, and this would be a legacy sample for the low redshift anchor in order to do dark energy measurements with missions that are soon to come online, like the Rubin Observatory and the Roman Space Telescope in the future. Now, looking into the sample characteristics, we're comparing it to the current low redshift sample. The median redshift is twice that of the current low Z sample, and therefore this is a sample that is a lot less impacted by peculiar velocity uncertainties, which is a systematic in final cosmological inference. In addition, in the bottom histogram, we see that the discovery epoch is around 2 weeks earlier than the median from the literature. And this is particularly important. So there's an example light curve fit with the model that is used to infer light curve parameters for cosmology, the SALT2 model. And we see that there's a dense sampling near the rise of the supernova. And this is important because there have been studies in the literature suggesting that the early light curve can improve the distance estimate and reduce, therefore, the intrinsic scatter in the supernova distribution, and as a result, also improve the uncertainties on the cosmological parameters. This hadn't been previously possible because of low statistics of supernovae that have these early discoveries, but now, both because of early discoveries and the fact that these light curves go well beyond the existing light curve model, we can then retrain these models to have improved distances. When doing this inference of the RMS scatter, we see that comparing it to the low redshift, even with our preliminary pipelines, which use a custom reference and subtractions, as was done for the ZTF uniform depth survey, even with this preliminary version of the pipeline, we get a scatter that's very comparable to the current low redshift anchor, for which the pipelines have been developed over a series of years to decades. By looking at the host galaxy redshift sample, we find that the RMS is around 0.16, and that is something that can be significantly improved upon with current improvements that are going on with the pipeline. In addition, and this is the plot we see here, that's some ongoing work. We have a large sample of Type Ia supernovae in the more nearby universe. So typically between 15 to 60 megaparsec. And this is a typical calibrator distance, where here we see that we have a calibrator sample of a large number of Type Ia supernovae. So over all of phase 1, this is more than 50 Type Ia supernovae. In year 1 alone, this was around 10 Type Ia supernovae, for which we can get primary distances independent of Cepheid variables. So in this case, we will be putting in proposals to get tip of the red giant branch distances. And in this case, we would be able to build a unique distance ladder that goes both from the nearby universe all the way out to the Hubble flow, using the Hubble flow sample that is there from the year 1 data release. And that's some work that is ongoing. So I'd say stay tuned for that. So just the takeaway messages: we have a uniformly observed all-sky Hubble flow sample, along with calibrators that have been observed really densely with the ZTF cadence, and independent distances will be ongoing. And this early phase sampling, along with large statistics from a single system, is something that is extremely competitive for cosmology in the future. The RMS already is looking very promising, even with the preliminary pipeline, and updates to this pipeline are in the way. So, well, I'd say stay tuned for the distance ladder, as well as following data releases and analyses. Thank you.